In this lab, we are going to quantify the rate constant of a solvolysis reaction. This type of reaction is an SN1 reaction. The diagram shows the reaction in this lab. As you can see, the reactant is tert-butyl chloride, and water is used as a nucleophile. The reaction produces hydrochloric acid. To determine the concentration of hydrochloric acid produced, we are going to titrate the reaction at different time intervals with sodium hydroxide. For this lab, you will need these items and these 5 chemicals. First, prepare the solution of 30 milliliters of distilled water and 30 milliliters of isopropanol in a beaker. Add about 50 milliliters of sodium hydroxide to the smaller plastic bottle. For this, you don't have to measure. To drain water from a burette, remove the stopper on the top and open the stopcock. When the stopcock is parallel to the burette, it's open, and when it's perpendicular, it's closed. Before titration, wash all sides of the burette with sodium hydroxide and let it drain. Then fill the burette with sodium hydroxide and pass the 0 mark as shown here. There are 2 reasons for this. First, it's easier to get to 0 by removing solution than by adding, and second, it's because we need to fill the stopcock with the solution before we start titration. So open the stopcock carefully to get the solution to 0 and fill the stopcock with the solution. If you drain too much, add a little more sodium hydroxide. Now we are going to use a volumetric flask to make 50 milliliters of tert-butyl chloride solution. A volumetric flask is different from any other measuring glassware because of this tick mark. The tick mark is to measure only 50 milliliters of volume more precisely and with more significant digits than any other glassware. Weigh out 0.5 plus minus 0.02 grams of tert-butyl chloride to a tared volumetric flask. Transfer the water and isopropanol solution to the volumetric flask up to the tick mark. If you are nervous about going over the tick mark, use a pipette to add the remaining volume of the solution, using the glass as a guide for the solution so there is no splashing. Place the cap on the flask and invert the flask to mix the solution. Be sure to put your finger over the cap so that the solution doesn't spill. Once you've mixed the solution together, start the timer because you started the reaction by mixing. Then transfer the solution into the larger plastic bottle. Measure 5 milliliters of acetone in the hood. Acetone is the washer bottle you normally use to clean glassware in the hood. Acetone is used to stop the ongoing reaction and freeze the concentration of the product, hydrochloric acid, so that we can calculate the amount of hydrochloric acid produced by titration. Now we use a volumetric pipette to add the reaction solution to the flask. To fill up the pipette, stick and snug the pipette into the bottle and squeeze the bottle to push the solution up the pipette. Go past the tick mark. Apply pressure on the top and slowly drain the solution until reaching the tick mark. Then transfer the solution into the flask. In order to know when to stop titration, add a few drops of blue indicator to the flask. When you perform a titration, you want a slow, manageable dribble from the burette. The earlier solution's titrations, especially the first one, will be faster than the later ones, so be careful not to add too much sodium hydroxide at once. Once you see the color forming, reduce the speed of adding NaOH so you can get the accurate endpoint. You have reached the endpoint when 1 drop of NaOH causes the color transition from blue to green back to yellow. It all lasts about 20 seconds or so. Don't forget to fill the burette with sodium hydroxide before a new titration. When you determine how much sodium hydroxide was used for titration, you need to consider the meniscus. The meniscus is caused by liquid surface tension, and there should be a curve on the liquid surface. You read the volume line at the bottom of the curve. In this case, the flat surface touches around the 3.05 milliliter line, so that means that 3.05 milliliters of sodium hydroxide was used for the titration. Try to read to the 100th place.